12 talks about finding the probability of compound events where they have to occur at the same time. I want the of A intersect B, where the probability of A and B is the probability of A times the probability of B if A and B are independent events, meaning the probability of one doesn't affect the probability of another. If A and B are independent. If the chance that event A happens has no impact on the likelihood of B. So these two examples here this afternoon, let's just assume that these two are independent events. We'll talk more about conditional probabilities on a later standard. Well, here's the situation on multiplication. A math class here at Van Meter has 20 students. 7 of the students are blonde, 6 have brown hair, 5 have black, and 2 of them are redheads. 3 students are chosen at random for a group project. Find each probability. I want to pick 3 students, and in question 1, have all of them be blonde. So what do my students in this group look like? Blonde and blonde and blonde. Blonde. And blonde. And blonde. So if I want these three things to happen at the same time, I want to pick a blonde and a blonde and a blonde. I'm going to use multiplication rule and just multiply the probability of picking a blonde student 3 different times. How many blonde students are there? 7 of the 20 in total. So 7 out of 20 times itself 3 times. Right, so if we're assuming independent events, let's just keep everything in total. I'm selecting them all at the same time. Okay, not just like pick one, then pick one, then pick one. I'm picking them all at the same time. Just so I can use multiplication rule. What you're thinking of is a conditional probability that's coming later, Isaac. Seven out of 20 times itself 3 times, or 7 out of 20 to the 3rd power, is about 0.0429. Not very likely. Only about 4% chance that my 3-person group is made up of all blonde students. Okay, now let's work backwards here. No black-haired students.
Do you guys need lunch yet?
You guys need lunch? Go ahead.
How many in here need lunch?
No. Or just
One? Okay.
haired student. How many black-haired students? How many students have black hair? 5. So how many students don't in the class? 15. I want no black, and no black, and no black. So there are 15 out of the 20 students in the class that don't have black hair.
Mine's on purple. Actually,
So typing this in 23 times gives me about 42.19%.
you want to write down these 2?
Say again?
Yeah. Never mind.
What I'm looking for is this setup. If you just give me this decimal and it's wrong, and I don't have what you're trying to give you much, right? So show me what you're typing into the calculator, as well as that decimal that you're spitting out. Most of the work is coming in how you're figuring out what to type into the calculator anyway. All right, 3 and 4 are a little bit trickier. We're going to have to do this backwards. At least one redhead. My 3-person group needs to have at least one redheaded student. So what can my group look like if there's at least one redhead?
Yeah.
I can have 1 redhead, 2 redheads, or
You have 3. Or you can have 0.
I just can't have 0, right? Just 1 means I can have 1, 2, or 3. I don't want to sit here and think about, all right, all the ways I can have one redhead, all the ways I can have two redheads, all the ways I can have three redheads. That's gonna take too much work. Let's use complementary events. The opposite of at least one is none. So the probability of at least one can be found as 1 minus the probability of none. It's all outcomes that are possible, 1, 2, or 3 redheads, but just not none. Everything has to add up to 100%. Let's just exclude the probability I don't want to account for. Does that make sense? These are complementary events. The complement or opposite of at least one is none. So take everything minus the one you don't want to include anymore. I think that's a much more efficient way of finding the answer than sitting here and thinking about all the ways to have 1, 2, or 3 redheads. Okay? So 1 minus no redheads. How many redheads are there?
2.
Well, how many redheads aren't there? Well, it's minus 18 out of 20 40 times. One minus quantity, 18 out of 20. 2 redheads, leaving me 18 non-redheads. 27.1%. These are a little bit backwards. At least one means you can't have none. So take the chance of none and subtract. Okay. We're going to work with complementary events on line number 4. Not all brown-haired students. If my 3-person group is made up of not all brown-haired students, what could my group potentially look like?
0, 1.
Right. It just can't be all brown. It can't be all 3 brown. I could have no brown-haired students. I could have 1 brown-haired student, or I could have 2. I just can't have all 3. The opposite or complement of all of them, probability of not all, is 1 minus the probability of all. So to the probability of not all of them being brown, I can do 1 minus the probability of all of them having their brown. If I don't want to include the probability or the group where all 3 of them are brown haired, take that away from 100%. That'll leave me the probability of having none of them, 1 of them, or 2 of them with brown hair. 1 minus all of them brown. I have how many brown haired students? 6 out of 20. 3 different times. This is the only one I can't include in the probability because I don't want all of them to have brown hair. There's the probability of having them all with brown hair. Subtract that from 100%. Does that make sense? Let's see. 6 out of 20 times its times. 97.3%.
What colors are here? Purple?
2 of them are 2 of them are redheads. I don't want any redheads, so I need to look at the 18 other students that are redheads. That are not redheads. Having at least 1 redheaded student have 1, 2, 3 redheads. I don't is where I have no redheads in the group. So take all possible outcomes, 100% of them, and subtract off the one you want to exclude. At least 1 means I better not include the groups where I have no redheads on them. The opposite of not all students having brown hair is all of them having brown hair. I could have 0 students, 1 student, or 2 students with brown hair. I just can't have all 3. So exclude, subtract off from 1 the probability where all 3 of them have brown hair. Does that sound better now? There's one on the board behind me. I'll let you guys practice this one first. I've got 5 up there. 4 pieces of candy from a bag of Reese's Pieces are selected. The bag contains 45% orange, 35% brown, and 20% yellow candy. Assuming that this selection is independent, I'll describe below. How many pieces of candy are you drawing? How many pieces of candy were we selecting? 4. So be careful, because I was in my example previously only picking 3 students.
Jack, is the Underwood Mount Air game at Mount Air?
No. Yeah, probably.
Why is it?
Last piece is down. What would that?
They're not a district channel.
It's true.
What would the first 3 pieces of candy look like? If the last piece I select, the only brown Reese's Pieces, what do the first 3 pieces of candy look like?
Not brown.
Not brown.
Yeah.
So maybe you want to write it out. Not brown. And not brown. And last piece, there's the brown. 35% are brown. What percent are not brown? 35% are. What percent aren't? 65. So it's 65% times itself 3 times. But then the last one, that's the 35% of them. Answer should be in red.
Jack? No yellow, that means 3.
That's 4 straight no yellows. 20% are yellow, so 80% aren't. Take 0.8 times 0.8 times 0.8 times 0.8. Those last 2, number 4 and 5, think backwards. Not all orange. Means I could have 0 orange, 1 orange, 2 orange, or 3 orange. I just can't have all 4 orange, right? So exclude, subtract from 1 the probability of all 4 of them having been orange. At least 1 means they can't not, all 4 can't be not orange, right? At least 1 means you have 1, 2, 3, or 4 orange. You just can't have all not be orange. I need to subtract off the chance where there are no oranges.
Oh, since orange is 45%, I would do
0.55 times itself 4 times, but then subtract from 1 because I want to exclude the outcome where none of them are orange, leaving me all the other outcomes where at least 1 of them would be the orange Reese's Pieces.
Okay, so for not all orange.
Okay, not all orange, be 1, 2 orange. It'd be all 4 orange.
So do all orange.
Do all orange, but then subtract it from 1. Think about what you don't want to include in your probability. We're using complementary events. Think about the opposite of not all. The opposite of not all is all orange. So subtract that outcome. brown. No yellow. 20% are, so 80% aren't yellow.
So Gabe,
Yeah. All brown, 35% times itself 4 times. No yellow, 20% are yellow, leaving the other 80% that aren't. So take 80% times itself 4 times for the 4 pink. We talked about this third one. The last piece is the only brown. So the last piece is the brown. The first 3 were not. Not brown, the 65%. Times the 35% who have picked the brown on the last try.
once we're
Are
done
those
with
first 3 decimals lining up with what you're getting so far?
yeah.
In just 1 second.
Okay.
All right, these last 2 are more complicated because we're talking about more than one potential.
You do all you do try the probability of all orange.
And then subtract it from
1.
1 minus all orange. So 1 minus all orange. So 45% orange. I need that. At least 1 orange means it could be 1, 2, 3, or 4 orange. It just can't be all non-oranges. So 1 minus no oranges. 1 minus 45% are orange, so the other 55 are not. Much more likely on those last 2 than any of the first 3 scenarios. Any other problems?